Okay, so first of all, let me introduce myself. I am Jonathan Macera. I'm a professor at Tampere University. I work on biomaterials and tissue engineering, not really anything related to optical fibers. But today I will still be the moderator. I will replace Wilfried and Letitia for the time being. And today I'm pretty glad to announce that Kevin Boll will be the presenter. So Kevin is a product manager of the specialty fiber group in Rosendahl Nextrom, which is a world leader in optical fiber manufacturing equipment. He has an extensive background in manufacturing equipment and has been in the optical fiber industry for over 15 years. And he has been publishing and presenting in leading journals and in various international conferences. So I hope you will, I'm sure you will enjoy his talk. And now I will leave Kevin presents his speech. Thank you for being here.
Thank you, Jonathan, for presenting me. Hello, everyone. Hopefully, next 30 minutes will be interesting, talking about the manufacturing of specialty optical fibers and the challenges both from the manufacturer's viewpoint as well as from the equipment manufacturer, and they kind of go hand in hand. I will start sharing my screen here. And okay, hopefully everybody can see this now.
Looks great.
So as I started preparing this slide, the idea was to go through spend more time on the manufacturing challenges based on for the fiber manufacturers and what they need to do in order to stay profitable, to keep up with the market. But as I started making this, I realized that you can't understand the challenges without going through the differences in the actual fibers themselves. And that by going through that is how I'm going to be able to give more of a overview on what those challenges are. So what my plan is to quickly go through specialty fibers. There's so many of them. There's a huge variety of different fibers. I'm not going to go into details about that, but talking about the differences, different challenges in them will then move us into the manufacturing challenges, the opportunities that the manufacturers have. There are many good things in the market. It's not just challenges. And then I'll present a little bit. These will kind of flow together a bit on the Rosendahl Nextrom side as an equipment manufacturer, the challenges, what we do to try to assist our customers to solve their problems. And then at the end, talk a little bit about what I see that the market needs in new applicants, new resources as they come in, what would be valuable skills to bring. So if I start off, what is a specialty fiber? In some way, it's very easy because I can say it's not a telecom fiber and it's everything else. So that's the easy description, but the hard description is really what is it? Because there are many types of specialty fibers out there for a variety of different applications. This was just a list I put together off the top of my head. I'm sure if you talk to different manufacturers, they will separate these into further subgroups or have many different ideas about how to group these. But you can see out of these 17 different types, then each of these have different sizes, different requirements, different specifications in each of these subgroups. And you get to start to understand about the large variety of different fibers that are out there that the manufacturers have to consider and find and support their customers. If we look at the different applications that these go to, the main, let's see, I'll walk through that quickly, but the main 5 that I see are fiber lasers, and this is a very large, there are probably 2 to 3 very large sections of this with then smaller ones as we get further down the list, but definitely the fiber lasers and the fiber sensors are the two biggest categories of specialty fibers. And they're going to include the large diameter doped core, dual cladding with different non-circular cladding. The fiber sensors is a huge genre to go through because there are sensors for almost anything you can think of: stress sensors, acoustic sensing, temperature sensing, pressure sensing. It's there, and in many various applications that can be from highly radioactive to corrosive environments, high temperature, low temperature, long spans, short spans. It's really a huge variety. On the gyroscope side, that's mostly a polarization maintaining fiber. You have medical. This is definitely a growing field where both for laser beam delivery for surgeries, as well as more and more sensors are using optical fibers for non-invasive type sensing. And then radiation resistant fibers that can be used in space, nuclear applications. The next few slides, what I'll go through are the main differences in the specialty fibers. Again, I won't talk about all of the differences. But if we talk about starting from the core, the main differences are going to be that if you have a passive versus active core, either a pure silica core, a germanium doped core, or then a rare earth doped core, which is used in fiber lasers. Then you have differences in the core shape, with some pictures here of panda fiber, as they call it, or bow tie fiber, or looks like the Star Wars TIE fighter, or the elliptical core fiber. And what these are going to do is maintain the polarization of the light as it goes through. You have Bragg grating, where you have slight deformation in the core to create a reflection at certain points, and then you can measure the spectral response for the transmitted and reflected, and then you can measure by measuring or observing any change in this reflection. You can measure what's happening in the fiber, whether it be it bending or stretching. So that's mainly used for structural stress sensing. Multi-core fiber, so you can actually then combine many different things or types of fibers into a single fiber, so you can be measuring temperature, pressure, stress, all at the same time. And then coating materials. There's a very huge variety of different coating materials based on the need. You have a standard dual layer UV acrylate, similar that is used in telecom fibers. Then low index coatings, hard clad, perfluorinated coatings, thermally cured, such as polyimide or silicone curings, metal coatings that can be used for hermetic sealing or radiation resistance. And within that metal, it can be aluminum, gold, silver, copper, and then carbon coatings used for hermetic sealing. So this is putting a thin layer of carbon directly on top of the fiber and then coating on top of that with something else. You can also have, as I missed here, a PTFE jacketing or some sort of extruded jacketing directly on the fiber. Then the outer shape can be different. You can have different ratios, core to clad ratio ranging from a very small or a large ratio to a small ratio. Large, especially the larger core sizes are used in the fiber lasers. You can have the shape cladding. So this is a hexagonal cladding. And in this type of fiber, the pump light is put into the cladding, and with this non-circular shape, it will it will ensure that the pumped light will move into the core, where you have a then doped core with the rare earth doped ions that I had mentioned earlier, and that's to create the lasing effect. Then beyond all of that, we have non-solid fibers. So you have microstructured fibers where you have the light still guided in the core, but you have air gaps in different configurations around the core. You have hollow core where the light is guided into the air core, and you again have the structure around it. The advantage of the hollow core is that light travels faster in air versus glass. And also the theoretical loss is lower. However, they are very difficult to make. Up until very recently, there's been significantly higher attenuation in these hollow core fibers, but just, was it 2 weeks ago at OFC conference, Luminicity announced quite stunning result on their, anti-resonant nested fiber, which is this one here, where they were getting better than 652, better attenuation and across a wider band than a standard single mode fiber. So that was a quite promising development from them. So those are the varieties of different fibers. And you can see from that there is a huge difference of fibers of equipment that would be needed in order to make all of those. So one challenge that the manufacturer has is they need to define, first off, what types of fibers are they going to make? None of them can do all of it. And all of the fiber manufacturers have found or concentrate more on one area than another. It may be more laser fiber, it may be sensor fiber. Certain ones will concentrate on maybe non-silica based or different coatings. But they first need to find that market and define where their limits are going to be, and then specify their equipment accordingly, but still maintaining the flexibility in the equipment. For the different fibers, for a variety of different reasons, you have a wide range of different drawing speeds. The most basic reason is during the fiber draw, the fiber needs to cool down enough before you can put a coating on it. And for a standard acrylic coated fiber. And most of the time that's done just purely by letting it cool down in the air, and that will then limit your drawing speed accordingly. The larger the diameter fiber, the more heat you have stored in that, more energy you have stored, and then therefore the slower the draw speed. You can add forced cooling with helium, but there's a cost to that because helium is an expensive resource. Then other factors may affect the drawing speeds. The coating materials vary. The thermally cured materials, for example, tend to be below 25 meters per minute, where the acrylic, there are specialty fiber manufacturers probably running in the 500 meter per minute range. That's going to be on the upper end. For a telecom manufacturer, our current telecom tower is approximately 3,000 meters per minute. So there is a lot of room for growth in drawing speed if it's needed, and I'll talk about that a little bit later. Then again, going back to the flexibility of the equipment, you have all of the different coating materials that I talked about, trying to find systems that are flexible, that can be used with multiple different coating materials. such as the UV acrylate or UV curable acrylates or a thermally curable. You may be able to apply those with the same applicator, but you need different dyes, dye setups for each of those. But then of course you need different curing, how to be able to switch back and forth quickly and efficiently is a constant consideration for customers. The fiber sizes and shapes, as I talked about the different diameters, you have different needs for lengths, and specialty fibers may not even be truly a fiber. They can go up to millimeters in diameter, and at some point you refer to them as a cane or a rod rather than a fiber. And that again requires different equipment, because as the diameter of the fiber increases, the minimum bending radius is also increasing accordingly. And you're no longer able to bend it around a turn wheel, for example, or wind it onto a reel, and you need to cut in straight lengths. Other challenges are falling fiber prices. There has been a drastic drop in fiber prices over the past, well, I guess it's been kind of continuous. I'm not directly in that market, so I don't follow it as closely, but it matters to me because obviously it matters to my customers who are producing the fibers. And they are saying, the feedback that I get is that we need to continue to reduce equipment costs because fiber prices, fiber margins are reducing. So everything kind of slides down. It's a typical process in any manufacturing. Specialty fiber is still a relatively new field. There's new applications, new products coming out, and as any product becomes more developed, costs come down. You have more players in the field that will find new ways of doing, more efficient ways of doing things. So it's a constant push to reduce the cost. So here you can see this. I did have the data that the polarization maintaining fiber for gyroscopes has fallen from $10 per meter to $1 per meter. And I know there's been somewhat of a similar drop in prices for a rare earth doped active fiber, but I struggle to find a good chart showing it. Because I think part of the problem is that there's just too many varieties. You can't just define an active laser fiber. You have different core sizes and different doping, different dopants, different lengths. Everything can change. Then related to all of these different types of products, once the manufacturer defines this is what we're going to make, this is our business model, how to remain flexible to the customer, because there's different applications, different customers are coming constantly asking for special fibers, special designs. How to design your manufacturing that you can have this flexibility to provide for your customer requests while also maintaining a stock of what can be hundreds of different fiber types. Making custom fiber is a challenge because first you have to define the type of fiber that's required. You have to design the preform, the dopants, and you don't always get that right on the first try. So you're going to be making multiple preforms, or you can require to make multiple preforms for this one fiber that the customer may only need a few meters. So now making preforms, an average preform may take 8 hours to make. Then you have to, 8 hours to produce, deposit the glass, some more time to collapse the preform, then you have to draw it. And if the customer only needs a few meters, that means that those few meters are going to be extremely expensive unless you can sell the rest of the fiber, which is, you're not sure. Do you put that in stock? Do you just tell your customer, no, I'm not going to do that? It's a constant negotiation and challenge for the manufacturers of how customizable are we going to be? If we only do standard fibers, is there enough of a market? And are we going to lose customers to the more flexible manufacturer? So there's a lot of challenges that I just went through with so many different products. Why do it? The answer to that is that it's still an attractive market. You can see that the markets have been growing quite continuously. This is the top graph here is specifically the fiber laser market, or the laser market. And you can see that the laser market itself is growing quickly from 2014 to a projection in 2025. And then the green here is the fiber laser. And you can see that it is basically the growth has been taken up a vast majority purely by fiber lasers. They've become much more efficient, much better beam quality, and been a continuous increase in power. So the application range for a fiber is continuing to grow, where years ago you may not have been able to use it for material cutting or welding because it wasn't enough and it was only an etching process. Now there are multi-kilowatts or tens of kilowatt fiber lasers out there that are doing most of the metalworking that you see. Then on the sensor side, you can see this is the gray line is the distributed sensor market. And again, from 2016 to 2026, there is a almost doubling of the market. And these distributed sensors are, optical fibers are very attractive for that. It's much easier to make a distributed fiber, a distributed sensor using an optical fiber, because by using Bragg gratings, you can write a grating every X meters or kilometers, and by using the same fiber and measuring the time that it takes the light to reflect with an OTDR, you then can, any change in the position of that fiber, you can relate, or you can measure exactly where it is along the fiber. So there's a lot of advantages on all of these sensors, or on fibers, and that's why it's a growing market. The other one is price attractiveness is still good, especially if you compare it to telecom. The telecom fiber 652D really crashed a couple years ago, and it was down below $4 per kilometer in China, which is just unbelievably low. The manufacturers can't make money off of that. So I was noticing the specialty market noticed a switch that fiber manufacturers were trying to get into the specialty fiber market because of the price attractiveness. Using just one example, I went on Coherent's website that they have online pricing for their fibers, and you can see that the most expensive fiber is over $750 per meter, and with a standard preform size, you get about 5 kilometers from that. That's $3.75 million from that one preform, if you can sell it. But that comes back to the problem of you have this expensive or valuable preform that a customer needs 5 meters out of, and you have 5 kilometers. So what to do with that? So all of these challenges, the question then is, what does the manufacturer need to do to stay competitive and profitable? And I'll talk about then moving into the equipment as well, how the Nextrom equipment tries to help out with this. So one way, well, improving quality and performance, this is an obvious one. You can gain a price premium if you can guarantee your customers that this fiber is more reliable, better better specifications, whatever it is. And that's related both to equipment, quality of equipment, as well as your processes, making sure that you have a very lean manufacturing, reducing faults, really analyzing the production quality and continuous improvement on that. Then increasing productivity to reduce costs is something I'm really seeing in the market now. As prices have fallen for certain products, they've been made up for with the increase in demand. And specifically for certain fiber types, they're basically a commodity that every main large fiber manufacturer keeps in stock. And I'm seeing more of a trend going to larger preforms for these types of fibers, larger or higher drawing speeds, really moving more towards a telecom, not in the same ballpark as telecom speeds and heights, but moving that direction that they're going to have a single product with larger volumes, that they're using some equipment to only make one product as fast and as cheap as possible. And then they have more flexible equipment. So that means larger towers, increase in height, increase in preform sizes. With Nextrom, for example, has recently developed a draw furnace from that our previous size was 50 or 60 millimeters, and now we have 100 millimeter, where 100 millimeter preform 10 years ago, there were 15 years ago, there were telecom manufacturers making 652D with 100 millimeter preforms. And then ensuring that your processes and equipment are reliable, that you have good startup, good processes, and repeatable, that you can start your drawing process faster, that your proof testing process is very lean and everything is run and well organized and planned. And with that lean manufacturing, you need the data from the equipment. So all of the equipment that we deliver has full data logging capability, and all of the analysis and fault analysis online, fault sensing, for example, reducing waste, or we have equipment that can mark faults during the drawing process. So if anything goes out of spec with diameter, concentricity, something out of spec, we can put a black ink mark on that out of spec fiber for easy identification and cutaway to try and improve all of the processes for our customers. Then it's important that the equipment that the fiber manufacturer has is flexible, that they really have an agile production. They can quickly switch between products, one day running one diameter, later in that day, another diameter, another preform size. So the flexibility in equipment is critical in order to make this large variety of different fibers. Like I'm running out of time, I'll have to move a little bit faster. Then the last thing I think is key to profitability for the manufacturers is finding their own niche area. When I talk to all of my customers, all of the fiber manufacturers, they all have a few products that they do very well. And everybody knows that they sell those are the cash cows. And they support the other products that are maybe more up and coming, that aren't so profitable now, but maybe in the future, and that they want to make sure that they're still in that game in case, because nobody knows exactly where the market is going to go. All of this also means we have challenges as an equipment manufacturer. Rosendahl, Nextrom, we are only an equipment manufacturer, so we are providing equipment to our customers, and but not making any of the products ourselves. We can do testing, but not on large scales. And so it's very technical equipment, highly technical equipment in chemical vapor deposition processes, high temperatures, corrosive gases. So they're highly customized machines. Differences in different markets means we have wide different product ranges. For example, the telecom versus specialty market have completely different needs, where telecom is trying to make essentially one product as fast and cheap as possible, where specialty, as I just talked about, the variety and the flexibility is more key. But it's a challenge to keep that flexibility while also watching or trying to reduce costs as the market grows. I kind of skipped over this. There's also a large fluctuation of sales volume between different products. We at Nextrom have some product ranges that can fluctuate from 40 million one year to 0 the next, and then back to 40 million the next year. So organizing for that is quite difficult. So how we overcome this, within our group, we have multiple different groups that operate somewhat separately, although still under our kind of group umbrella. So we have a shared operations, shared procurement and assembly team, but our specialty fiber group, for example, is working more independently on the engineering and process sides, because the different needs for customers between the telecom, for our telecom product range and our specialty product range, is very different. So we have to make sure that we have our resources trained in multiple different areas, that we can switch between them as we have fluctuations. Luckily, on the specialty fiber side, we've seen this constant growth over the past 10 years, so it's been easier to keep resources. We haven't had the ups and downs. It's been more just increasing and trying to keep up with that. And we have to make sure that we have key resources that are well-trained and knowledgeable in the end products, so that we can design the equipment efficiently for the end product and not over-design. One of the challenges or problems that you'll see with someone who doesn't understand the end product, you have to over-design everything so that you're sure that it works. So the knowledge of the process, the manufacturing process, the end products is really key to making really sharp equipment doing exactly what it needs well without waste. And then I skipped over the other challenge, recent challenges of COVID restrictions. And that's been a challenge as an equipment manufacturer, because we have these large machines that we have to go and install and do commissioning on, prove that they're working. And we had a couple of years where there was not really the opportunity to travel. So we were forced to train more local resources and expand our capabilities. Looks like I'm up for time. I only had a few slides left, so if it's okay for me to talk another 3 or 4 minutes, Jonathan?
Please go ahead.
Okay. All right, so quickly, I wanted to, I was told I would have the opportunity to give a little bit of a sales presentation for Nextrom, just that people understand who Nextrom is, what we do. So as Jonathan mentioned, we are the largest manufacturing or equipment supplier for optical fibers in the world. We are the only supplier that can provide the full range, from making the preform to drawing it, cabling it. We provide all of the different solutions. We have preforms by VAD, MCVD, FCVD, OVD, PCVD, sand cladding. We have the other sintering and stretching equipment for telecom fiber drawing here. We say 2,500, reaching up to 3,000 meters per minute, 1,000 kilometer spools. And I know most people here are working in the specialty fiber product range. And when you hear about 3,000 meters per minute and 1,000 kilometer spools, basically 1 day of production is enough for years of consumption of specialty fibers. It's such a different world. And it's really impressive to see these telecom fibers, telecom towers operating at such high speeds. Then we have coloring, ribbon lines, blown fiber lines. We have a wide range of fiber optic cables. Also, this ties into our sister company, Rosendahl. We are actually Rosendahl Nextrom. We are one company. We still maintain a Nextrom brand and a Rosendahl brand, but there is some overlap in our cabling equipment. And then on the specialty side, I guess we've gone through this mostly, that we have MCVD, FCVD, vapor phase doping for rare earth, sand cladding for PCF or multi-core fibers, PCVD, and then we have specialty drawing tower with a variety of different coating and preform sizes, specialty proof testers, quite extensive range of products. And we are located worldwide with our main operations in Finland, our mother company is in Austria, and we also have sales and service in the US, Russia, India, China. And my last slide, I was asked to kind of then tie this all in. What do we need from the market or from new applicants, new people joining? Those are our challenges, and how do we continue moving the market forward? And what I see is there are really two main things. One is really the understanding of the fiber and their applications and how they're made. But more importantly, no matter what we're doing, is the structured approach to process improvement. That means understanding lean processes, understanding whether it be for design or manufacturing, any development, you can use these structured methods for process improvement and process development, whether it be Six Sigma, total quality management, lean manufacturing, PDCA. There's a million of them out there, but it's using them in an effective way to ensure that you're moving the product forward in a structured and deliberate way. I had a discussion with one of the fiber manufacturers, specialty fiber manufacturers, a few months back, and he told a story about how their product production was running well. He was just kind of down looking at their draw tower, and he watched a guy fiddle with a knob, and he was asking what that does. And he's like, oh, on this draw tower, I have to turn this knob to the left. I don't really know why, but it makes it work. And he realized that they didn't have a structured approach to how to ensure that all of their fibers were going to be repeatable, because you had one operator is going to turn that knob a quarter turn, the next one's going to turn it a half turn. And very quick, so he went and made a structured process of all of their analyzing their fibers in a structured way, and was able to improve their yield almost immediately just by getting that structured process in place. And I think it's very key for all new applicants to understand these, and that will help no matter if you join a equipment manufacturer such as Nextrom or a fiber manufacturer, whatever you're doing, that process improvement is going to be invaluable. And the last one I would say is independent problem solving skills. Everyone's busy these days. No manager has time to micromanage. Everybody is looking for an applicant or a person who can solve a problem. You give them a problem, they come out with a solution. And that's another invaluable skill. So if any of you are good at that, please apply at Nextrom. And I think that brings me to the end of the presentation. A little bit over.
That is okay. Thanks a lot for your presentation, Kevin.
My pleasure.
That was really interesting. So do we have any questions? So John, please go ahead.
Oh, I didn't have a question. I was just virtually clapping.
It's virtually clapping. Sorry, I mean, it was like raising a hand. Sorry.
I think
virtually say thank you.
Jonathan's used to me asking questions, I think. But yeah, no, Kevin, I was just again virtually clapping my hands. I thought that was very nicely done.
Thank you.
So if anyone has any question, you can either write them down in the chat and I will read them, or you can just raise your hand and I will. Oh, okay. So Hossein, please go ahead.
Hi. First of all, thanks for very nice presentation. I have a question regarding the active fiber. What is the limitation to have high doped active fiber? Is it related to the quenching effect or something else?
That's a difficult question. I'm not going to be able to go through all of those or all of the things. So there's two ways to make the active fiber. So you can do it in a solution doping, which has been the more traditional method. And that's taking during the deposition process before consolidating, when you still have the soot, you then put a aqueous solution, including rare earths, inside of the tube, and you let that soak in. Then you evaporate the solution, which leaves the rare earths behind. The problem with that is that you don't have the flexibility in order to get high doping or differences in layers. You're limited on thicknesses. It's just not as flexible, but it's working. I mean, that's what the standard has been. Market is definitely moving towards vapor phase because that is putting these rare earths into vapor form and depositing them along with the glass. And the advantage with that is you can adjust your vapors during the process. The challenges with that is there's clustering. These rare earths are chelate form and you evaporate them, and they have to be held at 200 to 250 degrees. If they are not, they start to condense too hot and you will degrade them. So there's challenges. And then also you're using an aluminum to modify the matrix that you get the bonds for the rare earths. And if the rare earth and the aluminum mix prior to the deposition, you get clogging of your lines. The chemical reactions, you have chloride, so you can get some contamination, rust in the lines through hydrochloric acid. So there's a lot of things that go into that. And I don't think you can say that there's one specific thing that is limiting the higher doping levels, but as you try to go higher, all of these problems get worse. You have more problem with clogging, you have more problems with clustering of the rare earths and things like that.
Thank you very much. And my second question, as you know, very low numerical aperture fiber is demanding for new application, especially for high fiber lasers with high beam quality. What is the challenges for having very low numerical aperture fibers? Is it just related to the difference between the refractive index of the core or clad, or there are some problem in manufacturing?
I'm going to claim a little bit of ignorance on this one. Low NA is not typically what I hear. High NA, I think, is what more manufacturers will go to or are pushing for because it's easier to pump into the core. The low NA then will require a smaller core size. And I think one way of going about that is through tapered fibers. I don't think I had any pictures of that. But I apologize. I'm not so familiar with the low NA, and I don't want to say something that I'm not sure about on that. So I'm not able to speak too closely on that.
Thank you very much.
Any other questions? I cannot see any hands raised. Well, if no more questions, I think we can virtually clap our hands to thank our speaker, Kevin. That was a really nice talk. And I encourage everyone who is working on optical fibers to definitely take a look at the Nextrom. Clearly, they're looking for some bright students.
Absolutely.
Thank you all for attending, and I wish you a good day.
Thank you, everyone. And thank you, Jonathan, for moderating.
Thank you, Kevin.
Bye.
Bye-bye.